So now this is getting a little conceptual. Let's just recap what we've got. We've got a ball that bounces around on the screen. We got this paddle that does not work, but it moves left and right. Our paddle will move, but it won't bounce the ball. And also you can run it way off the screen. So here's where we're going to have to talk about a little bit about spatial perception. And let me see if I can find something that I can use to draw this stuff. Let's, maybe, will this guy work? Okay, well, yeah, okay. Yeah, so, well, let's just I just want to draw things. Let me draw things. Let's do, all right, well, let me do a snip of this. So I've got this snip. Now, here's what I want to talk about. This corner of the paddle. Where is this corner of the paddle? The corner of the paddle is at px, right? So this is px. This corner of the paddle on the x-axis, which moves left to right. Okay, so this, let's say, right here. This is px. Okay, everybody with me on that? And we've been changing px to make it move left and right. Now, what about this right here? The y-axis coordinate of the upper corner is what? That's py, right? Is everybody with me? So this corner, this is where it's at, this corner right up here. It's px and py. Now, we are just changing px to make the thing move left and right. What is this? Well, we know that the y hasn't changed, so it's just py. What is px here? This is actually the original px plus what? Plus how wide the thing is. So this is px plus pw. It's the x coordinate plus how wide it is, right? Everybody with me? This is where, like, I hope your brains are just on fire going, yeah, that's right. That's it. Okay, what about this one? This guy is px, but it's py plus the height of it, right? So this is py plus ph. Py plus ph. So in this one, the x coordinate hasn't changed, but this is also py plus ph down here. Okay, so you can see that if we start with this point, we can figure out what this point is by adding the height of the paddle, etc. So what we want is if this ball, now what about this ball? This is bx and by, right? By. That's this point. What is this point here? Let's change the color. Color of my maca. Make it orange. What is this? Well, it's still by. By didn't change. The y coordinate didn't change. But the x coordinate is different, right? So like y, it didn't move up and down, but the x coordinate is what? It's bx plus the width. I can't even see it on here. Bx plus bw. So you see that? So if we know this point, we can calculate what all these other points are by the width or the height. So like this point would be, the by has changed now, so it'd be by plus the ball height. Then it'd still be bx. Here, it'd be bx plus ball width, and then by plus ball height. So does everybody see that? This corner is the x and y coordinate, and then this is the x coordinate plus the width. X coordinate plus the width. Everybody with me on that? So when we do that now, we can figure out all this stuff with some mathy math. Okay, first thing we want to do, we don't want this paddle to run off the screen. That's just bougie. We do not want this. That is just sketchy, and we don't want it. So like, I don't want to be able to do that and make the paddle disappear. So the way I would handle that is, we've got this. I would just say that if px is, if p underscore x, make that bigger again. If it's less than 0, then p x is equal to 0, right? Everybody see that? And then put in an elif because it can't hit the left and right boundary at the same time. So elif p underscore x. All right, so here, if x hits what? The width of the whole screen, right? So wide, if px is greater than wide. But I don't want to do it when the left corner of the paddle hits wide. That means the paddle ran off the screen. So minus pw. What am I talking about there? Let's go back to my little drawing. So here's my paddle. If px is at the end of the screen, then that means px is here. And the paddle is like there, right? So I don't want it to stop then. I want it to stop when this thing hits the end of the screen, and this is px plus the width. Right, so px will be here. The width will be there. Or I'm just handling it backwards by saying wide minus the paddle width. So, and then we'll say that px equals wide minus p. I think that'll work. Let's find out. Let's run my code. Here we go. I'm going to try and run this paddle off the end of the screen, and now it won't go. Let me run it the other way. All right, it will not go. So now what we need is a collision event, because this ball just kind of runs whether it hits my paddle or not. My paddle doesn't change direction with the ball. So what I really want is, see how when the ball hits the bottom of the screen, it bounces up? I want it to do that if it hits this paddle. So first thing I want to check is the x coordinates of the ball. Are they such that it should hit my paddle? Let's find out. So here's how I would write that if statement. First thing I want to do is check and see if that ball, if the x coordinates match. So I'd say if, and we'll say the ball x coordinate, right, is greater than or equal to the paddle x coordinate, right? So what we're saying is, does the upper left corner of the ball, the x coordinate of the ball, match the upper left coordinate of the paddle? So, but we're saying greater than or equal to, so we're saying, is the ball here or is it over here? And it just keeps going. Well, we want it to be less than this, right? So we'd say that, and the ball x coordinate needs to be less than or equal to the paddle x coordinate plus what? Plus the width of the paddle. So that'd be PW. So what does that mean? It means that, like, if the leftmost edge of the ball matches the edge of the paddle. But we didn't do that on that side. We said that it has to match. Well, actually, it should probably be ball x plus ball width. Right? And maybe ball x plus ball width minus 1, but let's just do it like this. And the reason is, if the ball is lined up here, we want it to bounce off. But also if, like, even if the right edge of the ball, and that is ball x plus the ball width. That's up with the left corner. I I know this might confuse some of you, and some of you guys are just like your brains are on fire right now because you're like, I cannot believe that is so cool. Okay, but all we're doing is we're checking for the x coordinate. The ball could be up here. We don't want it changing direction if it's way the heck up here. We only want to do it if the bottom of the ball is at the top of the paddle. So we need another if. That's ball y plus ball height is, we'll say, equal to or greater, maybe? Equal to or greater than the paddle height. Oh no, paddle y. Greater than py. All right, so then what do? We reverse the ball. So we change the y direction. Okay, let's try it. Oh, it doesn't like my code. What is wrong with my code? Oh, and I think in Python it has to be greater than or equal, like that. Yep, that made it disappear. All right, let's see. Maybe my code will work. Maybe it won't. Oh my goodness, I do believe that might have worked. Now, I want it to work even if the ball doesn't hit this thing flush. Even if the, like, so what I want to do is like have it hit like here. Yeah, looks like it's working. So it's working well enough. I mean, the goal is not to create a perfect video game for what I'm showing you. But what do we have now? So we've got collision events, right? So when something collides, we change direction. Or you could make it disappear entirely, right? So depending on the complexity of the game that you want to do. Now, just for some inspiration, I showed you a little bit of code on what Pong looked like. Probably the next iteration of video games back in the day was something called Space Invaders. So Space Invaders, this is it. Okay. It came out in 1978, and oh my lord, I mean, Pong set my hair on fire, and then this thing came out, and I thought I was never going to be the same. Now notice these characters are different though, like they're not just a ball anymore. I mean, this is getting a little complicated, right? So like, but what did it do? So what would happen is it played a little bit of weird music, but see, this thing is, you like your base station, you're shooting up at the Space Invaders while they move. Well, we can kind of guess how they move, right? But as they move, they also change shape. Like their arms flap up and down, their legs move left and right. Well, what they're doing is they're drawing one character here and then drawing a different character one position over. Then they draw the first character and they draw a different character. So this is a little bit like our paddle, except they've created, we would just have to add a button, like maybe the up button will shoot. Then we'd have to draw a projectile, right? Here's a spaceship that's running across the top. So this was the next iteration, and then after this was a game called Asteroids. Let me pull up Asteroids for you to see. Asteroids Arcade. So, and then these were like the first big three. So, I don't remember what year. Oh, 1979, so it came out a year later. So you push start, you get these little spaceships that fly around. So right now the spaceship's just pivoting, but you can hit a thruster, and then it'll give you direction. And you can probably already see how you would do this using your code, right? Like you would, you know, this thrust just represents a speed, x and y, and it looks like it disappears after a while. So it's like after a certain amount of cycles, you reduce the speed of it until eventually it just stays still. When you apply thrust, it paints a little picture here. And then you shoot these asteroids, and then they become smaller asteroids. So when the collision event happens, when you shoot these things, it makes a little explosion graphic, and then it creates smaller asteroids from the big asteroids until you don't have any. And it just keeps score with how many of these things you shoot. So then what would be another one? Like, I guess, Mario Brothers, right? And Donkey Kong. Donkey Kong was maybe the next one. Then Mario Brothers came sometime after that. Let's see what Mario Brothers looks like for those of you not familiar. This would be the arcade version. So all of these graphics are possible to do using Pygame. You could recreate this entire game exactly like this. It's possible to do. So, but we've drawn very crude things. So let me talk a little bit about drawing different graphics here. So we've got Mario and Luigi. Now, if you want to get, for instance, you want to draw Mario. You can kind of get like here. This will show you what Mario looks like, you know, so like you can draw Mario that way. So how would you do it? Well, these are just little rectangles. So you would have to draw like a rectangle that, you know, you might draw a big one here for his hat, and then you just draw a series of rectangles. Now, is that a lot of work? Yeah. I mean, yeah, of course it is. But it can be done. So I'm going to move this off screen, and then I'm going to go ahead and save this. File save. Well, it's already saved. Let's do file new. So let's call this one Draw Mario. So how would we do that? I mean, we had some code here. And then we import Pygame. And then what was it? Pygame rectangle, right? So to draw a rectangle in using Pygame, we would just do Pygame draw rect. And then we just have to define our colors. So Mario, for instance, Mario looks like he is red, white, blue, and black. So we'd have to say white equals what? 255. Oh, stop it. Red equals, and again, the red, green, and blue are easy because it's the colors here. So red is 255, 0, 0. Because this is red, green, and blue. That's what those three numbers are. Blue equals 255, comma, 0. Oh, no, it's 0, 0, comma, 255. And then if you want to know what the RGB code is for any color, just Google RGB code and then type the name of the color in there. But now we just need black if we're going to do a Mario. So that would be 250. Oh, no, it's 255, 255, 255. White is, oh, no, black is zeros. Sorry. 0, 0, and 0. Okay, so we've got our colors, and then I don't know, like we'll say MX will be the base location of Mario's. MX and MY, so we'll say M X equals 10, MY equals 10. All right, and then here we're going to have to do a lot of these things to draw Mario, right? Because Mario consists of a lot of rectangles. Like here's, I'm thinking that I would probably be talking about like this one, like this Mario from Pinterest. So this would be X, this would be the basic X and the basic Y. So at X of 1, 2, 3 is where we draw our first rectangle. We make 5 of them. So what I would say is MX plus 3, whoops, and MY, and then I'd make a rectangle. 1 is not like I'm going to say we'll make them units of 10. So the Y is going to be 10. X is going to be 50. All right, and we don't want it to be white, we want it to be red. Mario's hat is red. All right, so what don't you like about it? Screen. Oh, need to have a screen in there. Yeah, so I want to do Pygame init. We'll call this thing Mario. Okay, and we need to do screen. Here we go. So I copied it twice. And then size was this guy here. All right, so will that work? Yeah, well, if I move this after I define what size is. All right, so let's run this and see if I can start to draw Mario's hat. Oh, it doesn't like it. Untitled 0 pi. And we'll call this one Mario.pi. Okay, let's run it. And I don't see his hat showing up, so something didn't go right. Let me kill this for a sec. Close the program. Oh, I need to, yeah, so I need to create that loop that draws things. Yep, I need to do the specify run, create the clock, put that all in there. All right, so instead of all this business, there, and get rid of this and start drawing Mario here. Replace this. So don't worry about doing this. I'm just demonstrating how you can do it. So, all right, let's run it. Let's see, can we get a hat? Can I get a hat? My kingdom for a hat. There we go. There's Mario's hat. Okay, the start of it anyway. So let me kill that. And so what I just drew, what happened to my thing? I just drew that little thing up there. So let me move that over a little bit more. MX, let's start him over a little further. 40 and 40. Okay, so I drew the first little part. Now I just have to keep drawing rectangles until he's done. So MX plus, oh, probably should make that 30 there. Okay, so now here, let's go with 20. MY plus 10. Whoops. And then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 90, and 10. All right, so I'm going to draw another rectangle, and let's see what it looks like. There we go. All right, now, can you see what's going on here? So I'm drawing this hat. Drawing this here hat here. Oh, there's brown. So I'd have to look up, what is, oh, here's just brown. Chocolate sounds so much better than brown. But let's just do brown. That's 165, 42, 42. So brown. Okay, so next rectangle I got to draw needs to be a brown one. And it needs to, and notice now here, see what I did here was I moved over 3 to start drawing this hat and drew one that's 50 by 10. Then I moved the y coordinate down 1, right, by moving down 10, and then drew that part. Now I got to draw this little brown rectangle. So I'm not going to draw the whole thing, but I think you can see what I'm getting at here. And it's not, I mean, it's not the craziest thing. I might pause this and then finish it, but not make you watch me draw each thing painstakingly. But MX would be same, the MY would be another 20. This thing is 30 long, and he's brown. Okay, so does that look right? MXY, yeah, yep, let's try it. All right, so he's got brown there. Ooh, maybe you want chocolate, because brown looks kind of red, doesn't it? What's chocolate? 210, 105, and 30. Let me try that, because I like chocolate. 210, 105, and 30. I think I might have accidentally picked like a more elaborate Mario drawing. Yeah, kind of. What do you think this is? Is this yellow? All right, let me pause this and I'll see. We'll see how close I can get. Okay, so here we go. This is Mario, and to draw him, again, I just created a series of rectangles. So there's a lot of them. It's like each row takes up a lot of space. But if you did this, you could make him move, right? So like there's Mario as he gets drawn. And so I'm just going to put in a little bit of logic here. I slowed this down. It's only doing 10 frames per second. But MX is his X coordinate. So if I wanted to make him move along the X coordinate, just at the start of every loop, I'd just say MX plus equal 1. And then that should make him move. So let me see if it'll work. There we go. So we're making Mario move. Now, when you look at the way the games are done, they move and it looks like their whole body's moving. And what they're doing is they're just drawing two different images and they're flipping them around, or perhaps multiple images. But there we go. So this is just an 8-bit Mario. And you can make him move around the screen. So the idea being that it doesn't have to be a dot that you move around the screen. It can be a kind of complex looking character. So what does this mean to you? I will go ahead and put this code. Oh, I don't know. This code is not that important. Yeah, I'll post this code if you want to draw Mario yourself. But for the homework assignment, what I want you to do is to create some video game that involves some type of non-player character that moves around the game space, and then a player character. So for instance, the non-player character in the Pong example was the ball and the player character was the paddle. But you can have both of them move in three dimensions. Now, if you want to, you could have one fire a projectile. So if you want to try and figure that out, you're welcome to try it. I mean, what you're doing then is just drawing another very small rectangle and making it move using X and Y coordinates. So I'm going to go ahead and post this code, and then I'll write up the homework assignment. So again, with the homework assignment, what I want you to do, design an original game. Just come up with some kind of game. Have a non-player character and a player character and have them interact in some way. So it doesn't have to be that intricate, but they just, both of them have to be able to move. So I'll let you work on that for a while. Do not procrastinate on this one, because this is going to be a lot of work. So once you think about it and be working on this code, you should be trying to code this a little bit every day. I'll give you some milestones as we go along.